Hey, again, this is your instructor in ELX 203 Computer System Servicing. And we're going to discuss our module 4. Okay, so that is computer networking. In module 4, we have objectives. First objectives is you're going to understand the basic computer networking. And the second objectives is you're going to able to differentiate the type of network topology. And the third objectives is you're going to crimp network cable in straight and crossover through configuration. So what is computer networking? Computer networking refers to connected computing devices, no, such as laptops, desktops, servers, smartphones, and tablets. No, everything that any device that able to connect to the internet, they are called device, no, or computing devices, and an ever expanding array of the IoT or the Internet of Things devices such as cameras, door locks, doorbells, refrigerators, audiovisual system, thermostats, and various sensors that communicate with one another. Okay, so network topology, the meaning of the network topology is the configuration or topology of a network is key to determining its performance. So network topology is the way a network is arranged, including the physical or logical description of how links and nodes are set up to relate to each other. We can discuss or we can expand our discussion further when we go to the types, no, of the network topology. So what is network topology? Network topology refers to how various nodes, devices, and connections on your network are physically or logically arranged in relation to each other. Think of your network as a city and the topology as the roadmap. So just as there are many ways to arrange and maintain a city, such as making sure the avenues and boulevards can facilitate passage between the parts of town getting the most traffic. So there are several ways to arrange a network. Each has advantages and disadvantages and depending on the needs of your company. So certain arrangement can give you a greater degree of connectivity and security. So there are two approaches to network topology. First is the physical and the second is the logical. So physical network topology, as the name suggests, refers to the physical connections and interconnection between nodes and the network, the wires, cables, and so forth. So logical network topology is a little more abstract and strategic, referring to the conceptual understanding of how and why the network is arranged the way it is and how data moves through it. Okay, the way a network is arranged can make or break network functionality, connectivity, and protection from downtime. The question of what is network topology can be answered with an explanation of the two categories in the network topology. First is the physical category. Okay, the physical network topology refers to the actual connections, the wires, the cables, etc., of how the network is arranged, set up, maintenance, and provisioning tasks require insight into the physical network. The logical network topology is a higher level idea of how the network is set up, including which nodes connect to each other and in which ways, as well as how data is transmitted through the network. Logical network topology includes any virtual and cloud resources. So, any mga software, no? Kung gamit natin mga software nga monitor nato, no, ang mga computers kung kuha, no? Even sa pag turn on and turn off, no, sa ato ang computers, pwede na gani siya gamitan lang software, no, sa server. So pwede ra siya nga bisag walay tawo mo turn on as long as the server is on. So tanan nga mga computers connected sa network, pwede na niya ma on and off, no? Then pwede po niya ma-monitor, no, kung unsay gipang open sa every computer so sa network. Okay, what's the most common type of network topology? Okay, first is building a local area network or the LAN, that is the local area network. Topology can be make or break for your business. As you want to set up a resilient, secure, and easy to maintain topology. There are several different types of network topology and all are suitable for different purposes, depending on the overall network size and your objectives. So these are the types of the network topology. We have here number one is the point to point, that is two computers, no. Usually ang gamito nato aning um, types of cabling is the so-called crossover network. Uh, Crossover cable, no, nga through. And the second type of network topology is the bus topology. So pwede siya gamitan lang straight through, no, straight through. And we have here the ring. So forma siya og ring and the star, no. Usually, no, mga star ginagamit niya sa computer, internet cafe, no. They are using hub or router. And the tree topology is more than a hub. Usually ginagamit din sa WAN or sa wide area network or sa metropolitan area network, no? Sa mga sample Norso, sample kanisya sa CIT ni siya nakabutang nga router or switch hub, and kanisya sa CAS, kanisya sa education, then the others sa and they are all, no, tanan mga computer sa CIT connected to one switch, and this switch is connected to the network, no, sa tanan network sa whole campus. And we have here the mesh, another type of topology, and the last one is the hybrid, no, kanang internet. So tanan na, no, sa whole world connected to each others as long as ang imong data, no, for internet is wala ka nahurot, and ang connected ka sa router o sa wifi, no. So everything maka-search ka sa YouTube is or sa any Google search or any browser, you are already in the hybrid, no, topology, because around the world or around the globe are already connected to each other. Okay, so what is a star topology? By the way, ang hybrid is a combinations of all these type of topology, no. So from 1 to 6 topology are all, no, comprises i-connect na tanan diri, no, sa ato ang hybrid nga topology. So what is a star topology? Star topology is the most common network topology. Okay, is laid out so every node in the network is directly connected to one central hub via coaxial cable, twisted pair, or fiber optic cable acting as a server. So this central node manage. So this one is the central node. Okay, the this central node manages data transmission as information sent from any node on the network has to pass through the central one to reach its destination, and functions as a repeater which helps prevent data loss. So this function node or the central node, no? The central is actually it is a switch hub, no, or the uh, buwag natin siya o gatong switch, no, nadita na yung mga wires na connect. So hopefully, no, we can do some research, no, sa tuwang web karon, no, what is a switch hub look like. So ato ning lang tawo, no, what is a switch hub. So to Google, so images lang, no, para mapano what is a switch hub. Switch hub. Okay, switch hub or the node. So this one, no, usually mo ni siya atong makita sa kuha, no, sa internet. Kani sila nga mga images, no? So kung siya makita na to. They are all these are the switch hubs, no? Or the network hub. Okay, so proceed sa tuwang discussion. Then the next is what is the advantages of a star topology? So star topologies are common since they allow you to conveniently manage your entire network from a single location. So because each of the nodes is independently connected to the central hub, should one go down, the rest of the network will continue functioning unaffected. So atong lang tao, no? If this one is ma-failed ni siya, so kaning upat, no? Ning tulo, sorry, kaning tulo, the printer, also the printer, no? So these four devices are still functioning, no? So when siya ma-doubt ang duha, then this still connected, no? Or pwede na po siya maka-operate. So muna siyang sabot sa iyang kuha, no? So making the star topology a stable and secure network layout. Additionally, devices can be added, removed, and modified without taking the entire network offline. So disadvantages again, no? Another advantages of a star topology is on the physical side of things, the structure of the star topology uses relatively little cabling to fully connect the network, which allows for both straightforward setup and manage over time as the network expands or contacts. So the simplicity of the network designs makes life easier for administrators too, because it's easy to identify where errors or performance issues are occurring. Now the disadvantages of the star topology. So on the flip side, if the central hub goes down, the rest of the network can't function. But if the central hub is properly managed and keep it in good health, so administrators shouldn't have too many issues. So the overall bandwidth and performance of the network are also limited by the central node's configurations and technical specifications, making star topologies expensive to set up and operate. So pasabot ani sa disadvantages if this switch, no, madaot kaning gitawag nato nga central node. So okay, madaot ni siya, then the rest ng mga computers daot dili na siya mo connect to each others, no, or wala like handshaking, no? Okay, so the next type of topology is the bus topology. So a bus topology orients all the device on a network along a single cable running in a single direction from one end of the network to the other. So which is why it's sometimes called the line topology or backbone topology. So data flow on the network also follows the route of the cable moving in one direction. So advantages of bus topology. Okay, bus topologies are a good cost-effective choice for smaller networks because the layout is simple, allowing all devices to be connected via a single coaxial or RG45 cable. So sa atong demonstration later, no, we are going to uh, create a cabling sa RG45 using crimper, and also we are going to demonstrate the two types of cabling, no, sa RG45. We have the straight through cabling and the crossover cabling. If needed, no, more nodes can be easily added to the network by joining additional cables. So disadvantages of the bus topology. However, because bus topology uses a single cable to transmit data, they're somewhat vulnerable. If the cable experiences a failure, the whole network goes down. No? If maaari usa ka line sa atuang kable, no, maputol, then the rest of the network, no, nga mga devices nga nakakonect na dili po siya mo function. So which can be time consuming and expensive to restore. So which can be less of an issue with smaller networks. So bus topologies are best suited for small networks because there's only so much bandwidth and every additional node will slow transmission speeds. So furthermore, data is half duplex, which means it can be sent in two opposite directions at the same time. So when when the other computer send data and the other one is also send, so they can communicate each others, no, nga kuan sila ning somewhat like a walkie-talkie, no. So before siya mo receive, kinahanglan sa nga ang usa mo transmit, no. Then after transmission, so katong usa mo stop na siya, then ang next na pod is usa siya mo transmit. Okay, that is for the hub duplex. So this layout is not the ideal choice for networks with huge amounts of traffic. So the next is type of topology is we have what is ring topology, no? So we have the single and also we have dual ring topology. So first is the ring topology, okay? That is a single. Is where nodes are arranged in a circle or ring. So like this one, huh? Okay. So the data can travel through the ring network in either one directions or both directions, with each device having exactly two neighbors. This one, no? So na siya neighbor sa left and the right. And this one also, no? Ako siya neighbor na diri. If this device, no? Cell phone, na siya neighbor, and ako siya neighbor speakers. What he cannot communicate, no? Sa kanin siya, no? Sa kanin example, this printer, no? Cannot communicate with this one. If madakot ni siya, then there could be no communications, no, between the printer and rin na po na siya mawagi, no. Now if this one is already defective and this one is defective, then these two devices or computers, no, cannot print because putol din siya diri, then there could be no connection, no. Only this tablet or cell phone or the laptop, no, can print, no, sa ato printer. So muna siya, no, explanation sa ato ang ring topology, no. So since its device is only connected the ones on either side, when data is transmitted, the packets also travel along the circle, no, moving to each of the intermediate nodes until they arrive at their destination. So if a large network is arranged in a ring topology, repeaters can be used to ensure packets arrive correctly and without data loss. So only one station on the network is permitted to send data at a time, which greatly reduces the risk of packet collisions, so making ring topologies efficient at transmitting data without errors. So by and large, in ring topologies are cost effective and inexpensive to install, and the intricate point-to-point connectivity of the nodes makes it relatively easy to identify issues or misconfigurations on the network. So point-to-point is somewhat like a uh, using only one line, no. For example, uh, kining gitawag na to point to point antenna, no. So wireless ni siya, but kinahanglan ang imong transmitter ng antenna or the transceiver antenna is naka-focus siya, no, sa imong uh, another transceiver or kung imong antenna is serve as receiver, so kinahanglan yang imong beam, no, sa imong antenna radiation kinahanglan naka-focus yun siya dito sa imong transmitter. Kay mawala dili po siya maka-receive og data. Okay, the cons of ring topology. Even though it's popular, ring topology is still vulnerable to failure without proper network management. Since the flow of data transmission moves unidirectionally between nodes along its ring, so if one node goes down, it can take the entire network with it. So that's why it's imperative for each of the nodes to be monitored and keep it in good health. Okay, so nevertheless, even if you're vigilant and attentive to node performance, your network can still be taken down by a transmission line failure. So the questions of scalability should also be taken into consideration. So in a ring topology, all devices on the network share bandwidth, so the addition of more devices can contribute to overall communication delays. So network administrators need to be mindful, no, of the devices added to the topology to avoid overburdening, no, of the network resources and capacity. Additionally, no, the entire network must be taken offline to reconfigure add or remove nodes. And while that's not the end of the world, scheduling downtime for the network can be inconvenient and costly. So what is dual ring topology? No? The second type of the ring topology. So a network with ring topology is haptoplex, so meaning data can only move in one direction at a time. So ring topologies can be made full duplex by adding a second connection between network nodes, creating a dual ring topology. Okay, so pwede siya na magka-communicate. So if this line no, could be disconnected, so there could be possibility nga pwede na po siya maka-connect no kani siya. Ay sorry. Okay. So next is the advantages of the dual ring topology. No? So the primary advantage of dual ring topology is its efficiency. So because each node has two connections on either side, information can be sent both clockwise and counterclockwise along the network. So the secondary ring topology include in a dual ring topology setup can act as a redundant layer and backup, which helps solve for many of the disadvantages of traditional ring topology. Dual ring topologies no, offer a little extra security. If one ring fails within a node, the other ring is still able to send data. Okay, so what is tree topology? Our next type of topology or network topology. So the tree topology structures gets its name from how the central node functions as a sort of trunk for the network, with nodes extending outward in a branch-like fashion. Okay, however, where each node in a star topology is directly connected to the central hub. So a tree topology has a parent-child hierarchy to how the nodes are connected. So those connected to the central hub are connected linearly to other nodes. So two connected nodes only share one mutual connection. Because the tree topology structure is both extremely flexible and scalable. It's often used for wide area networks to support many spread out devices. So this is the image no, of our tree topology. So example, this is our college, no? College of Industrial Technology, and this one is the College of Arts and Sciences. So all the computers of the computer all the computers of the College of Industrial Technology are connected to a one switch hub, no? And also all the computers of the College of Arts and Sciences are also connected to a one switch hub, and these two switch hubs are connected to a central hub. So this is called a tree topology. Okay, if this hub will fail, so only the College of Industrial Technology can connect to our central hub. And if one of the computers of the College of Arts and Sciences, let us say all the hubs are okay, so if this one fails, so the rest of the computers can still connect no, sa atuang hub. If this one failed, so all of the rest three computers can still connect to the secondary hub. So this is what called the truth tree topology. Okay, so this is the advantage no, of the tree topology is combining elements of the star and bus topology allows for the AC addition of the nodes and network expansion. So troubleshooting errors on the network is also a straightforward process as each of the branches can be individually assessed for performance issues. So the what is cons? As with the star topology, the entire network depends on the health. Okay, so I think disadvantage no? Of the root node in a tree topology structure. Should a central hub fail, the various nodes branches will become disconnected. Though connectivity within but not between branch system will remain. So, muna siya naka-disadvantage. No? So, muna siya, if kani siya mag-fail, so the rest of that na connect is failed po. Pero, still, no? Wala man na-connect ang, no? Wala connection sa example na internet, no? Then, na-fill niya ang central hub. So, Of course, the rest of the computers not connected or colleges has no also connection. So, but still, no, pwede rin Japon na maka-work tanan mga computers, no, bisag na daot ni siya ang central hub. So, that is one of the disadvantages, no. So, because of the hierarchical, okay, hierarchical complexity and linear structures of the network layout, adding more nodes to a tree topology can quickly make proper management and unwieldy, not to mention costly experience. So tree topologies are expensive because of the sheer amount of cabling required to connect each device to the next within the okay, hierarchical layout. Then the last type, another type of the network topology is the mesh topology. So a mesh topology is an intricate and elaborate structures of point-to-point connections where the nodes are interconnected. So mesh networks can be full or partial mesh. Partial mesh topologies are mostly interconnected with a few nodes with only two or three connections, while full mesh topologies are fully interconnected. Okay, this is a sample of our mesh topology, but as you have noticed na nga, kuhan siya, kalas kayo siya wires, no? Because now that ring topology, that this one is connected, no? So we are going to use uh, more wires, no, to connect to each other. So that is what we call the mesh topology. So the wave-like structures of mesh topologies offers two different methods of data transmission. No? The first is the routing and the flooding. So when data is routed, the nodes use logic to determine the shortest distance from source to destination. And when data is flooded, the information is sent to all nodes within the network without the need for routing logic. Okay, so advantages of mesh topology. So mesh topologies are reliable and stable, and the complex degree of interconnectivity between nodes makes the network resistant to failure. So for instance, no single device going down can bring the network offline. The disadvantages of the mesh topology is incredibly labor intensive. No? Its interconnection between nodes requires a cable and configurations once deployed. So it can also be time consuming to set up. So as with other topology structures, the cost of cabling adds up fast, and to say mesh topology networks requires a lot of cabling in an understatement. And the last one is the hybrid topology. So what is hybrid topology? Hybrid topologies combine two or more different topology structures. So the tree topology is a good example, integrating the bus and star layouts. Hybrid structures are most commonly found in larger companies where individuals' departments have personalized network topologies adapted to suit their needs and network usage. So these are the samples of our hybrid topologies. No? So this one is what we call the star topology, and this one is a ring topology, and connected together, no, into a central hub. So it comprises, okay, no, di lang siya star and ring. So pwede mo siya ang tree topology, no, ato i-connect this ato ang hub to make it hybrid. So when we say hybrid is a combinations of different types of topologies. So advantages of a hybrid topologies is the main advantage of hybrid structures is the degree of flexibility they provide, no? As there is a few limitations on the network structures itself that a hybrid setup can accommodate. So, and the disadvantages of hybrid topology is, however, each type of the network topology comes with its own disadvantages. And as a network grows in complexity, so too does the experience and know-how required on the part of the admins to keep everything functioning optimally. So there's also the monetary cost to consider when creating a hybrid network topology. Okay, so that is all for our what we call this one, or our network types of network topology. Now let's proceed with the network cabling. Okay, types of network cabling, we have this straight through cabling and the crossover cabling. Okay, so this is our RG45. Okay, ato na siya makita ron ato ang ano. So these are the color coding for pin. So starting from this side is our pin 1, no? Pin 1. So pin 1, 2, 3, 4, 5, 6, 7, 8. And this one also, no, is 1, 2, 3, 4, 5, 6, 7, 8. So pin 1 is white green, pin 2 green, then okay, white green, green, white orange. Pin 4 is blue, and pin 5 is white blue, and pin 6 is orange, and pin 7 is white brown, and pin 8 is brown. But actually, no, in our if cause a straight through, no, making a straight through, actually ang connection anin niya, no, if sa each pin of our RG45 pin out. So pwede lang, no, any color lang, no, ang atong ibutang, no, sa because straight through na siya. So sabutan na kung unsay color sa imong pin 1, mo po na color po dito sa imong pin 2, no. So sample this one, this side, no, or this one, no, the side 1 and this are the side 2. This are RG45 1 or RG45 2. So kung sa color sa imong pin 1, may color sa imong pin 1 sa pikas nga RG45. Example, kung orange siya, so orange na diri. Then kung white green na sa imong pin 3, so white green po na sa imong pin 3. So pwede siya bali-balihon lang, no, or any order lang, no. Kung example, white green imong pin 1, so dapat white green po na diri ang imong i-connect, no. Kung unsay color sa imong pin 2, mo po na i-color ibutang sa imong pins sa other kaning RG45, no. So that is for straight through. So ato sa ni siyang end show, no. Ilang taon na to diri, no? So this one, no. So ato we have here a RG45, no. So ang pin 1 ani, no, starting sa diri nga side, no. Ang pin 1. So naani siya sa lalom, no. Ang iyang lock di siya maklaro, no. Okay. So tara. Ano na lang, no. So siya para maklaro. So by the way, no, amo ni siya ang lock niya, no. Kani siya lock sa imong network. Then kung ato siyang balihon, no, ang balihon. So ang pin 1 ani is kani ding side, no. Diri ni siya ang pin 1. Okay? Kung ano na siyang inanaon ng forma. Okay? So pin 1 is this one. Siya klaro, no. So ano yun lang. Pin 1 kani, no. This one is the pin 1. Then 2, 3, 4, 5, 6, 7, 8. Okay, so inana siya ang ato ang connection, no. So pin 1. So pin 1, this one, then 2, 3, 4, 5, 6, 7, 8. Nato siyang balihon, no. Ayang connection, ayang form. So this is our pin 1, no? Pin 1, 2, 3, 4, 5. So this is our ano, this one, pin 1, 2, 3, 4, 5. So next is crossover. So the crossover is simple lang, no, ato ang horizon, that is 1, 3, 2, 6, no. So ang pin 1 sa imo ang other side, mabutang siya sa pin 3, no, pin 3. So that is 1, 3, 2, 6. Dayon 1, 3, 2, 6. Dayon 3, 1. Bali-bali na siya, no? 3, 1. Dayon 4, 4, 5, 5. So ano lang, no? 4, 4, 5, 5. Dayon 6, 2. And 7, 7, 8, 8. So ano siya, no? 1, 1, 3. Okay? Pin 1, butas siya sa pin 3. Ang pin 2 sa pin 6. Okay? So, muna siya 1, 1, 3, 2, 6. Okay? 1, 3, 2, 6, 3, 1. Okay? 3, 1 because bali na po siya, no? Ang pin 1 na niya nasa pin 3. Ngayon, 4, 4. So, 4, 4, 4, 5, 5. Then, ang imong 6 is nasa sa 2. No? 6, 2, and 7, 7, 8, 8. So, muna siya ang atuang. Pero ang kuha na kita na, no, is 1, 3, 1, 3 connected. Then, ang imong 2 sa 6 connected. Then, ang imong 3 sa 1 connected. Ang imong 4 sa 4 connected. Ang imong 5 sa 5 connected. Ang imong 6 sa 2 connected. Ang imong 7 sa 7 connected. Ang imong 8 sa 8 connected. Okay? So, ato na siyang i-demo karon, no? Sa ato ang configuration. Okay? So, ato ni siyang i-kuha, no? Ato ni siyang i-follow. So, straight through ito. Ang ato ang connection. Okay? So, straight through. So, check kung record. Okay? Thank you. So, straight through. Okay? So, straight through. So, ako ni siyang i-kuha, no? So, we have here a crimper. Ito tayo crimper. So, ano siya, no? Ano siya ang crimper. So, kani siya mo crimp, no? Mo push sa mo ang kuan. Sa to ang RG45. So, ang itabuan ni, no? Is ato na siyang ibutang diri, no? Sa ato ang bali. Okay, this one, no? Ito ibutang siya dira. So, dili sa i-crimp ha. Tinala na pa ni siya yung wire nga na-connect. Okay, so we're going to create first the straight through, no? Straight through. So, ato sa rin siyang i-strip, no? Strip using this one, no? Kani siya nga kuan. Kani, no? Sa iyang tunga. So, this one, no? We're going to use this one for our shield, no? Kanang pagtangtang sa iyang cover. So, ato ni siyang ang wire, no? Ipasulod na ito ang wire. Tara. Then, we go sa ato rin tuyok ko, no? Ang atong wire. Ay, sorry. Tuyok ko lang ang wire para nga ma-remove, no? Okay, so that's it, no? Matang-tang siya. Yung cover. So, inside sa wire, no? Nani siya mga color coding, no? Sa ato ang hindi siya maklaro. So, we're going to follow lang, no, sa ato ang color coding. Okay, so our first color, okay? Let's go sa ato ang color coding. So, straight through ta, no? So, ato lang i-follow ni siya ang color code is white, orange. So, white, orange, and orange, no? Ato ni siyang tapos na siyang bungkago, no? Ang ato ang wire. Okay. So, white, orange, and orange. Okay. So, lanta lang wala sa, ano, sa kanang, drill na lanta lang sa ato ang guide. So, white, orange, orange. Okay. So, white, orange, orange. And next is white, green, then blue. So, tapos ang bungkago na sila, no? Yung mga cable. And brown, white, brown. Okay, then we have green, white, green. So, 8 nito ano, ang cable nga nari sa sulod, no? Uh, sa ato ang RG40, sa ato ang network cable. So, again, no? White, orange, orange, then white, green. Okay. Kanito white, green. Where are you, white, green? Nara. Okay. White, green, dayon next is blue. Okay? White, green, then blue. Okay, hindi naman klaro, pero kato lang, no? I-follow na to. Then, next is white, blue. White, blue, then green, green, then green, then white, brown, and brown. Okay, white, brown, and brown. Okay, so so you have here white, orange, orange, white, green, blue, white, blue, green, brown, white, brown, brown. Okay, so next is we are going to uh, para no as you have notice nga dili siya tupong no ang ato ang wire. So ato ni siyang gamitan ano no this one ani no this one para mo tupong siya no ang imong cable. Okay? So tupong na sila no so that one. Then ato na siyang i-insert no sa ato ang RG45 no. So pag insert ana kinahanglan ang imong lock nasa ilalom no. Ang imong lock nasa ilalom. Okay, so pin 1 is this one, no? Is pin 1. Ato siyang paano, sulod. Okay. Na you'll notice no, nga nasulod na sila. So, iwan siya ni siyang i-crimp, no? Using this one, no? Ito ganiya, no? Ato siya ipasulod rin. Okay. So, ato siya i-check kung wala ba nagbaylo. So, we have here white, orange, orange, then white, green, blue. Okay. White, blue, green. Okay, then white, brown, brown. So, sakto siya, no? Wala siyang nag-vilo. So, atong buhaton is we're going to crimp that one, no? Ato siyang i-crimp. So, ato siyang ipasulod, no? Sa atuang crimper. Then, ato siyang i-crimp. Okay? So, di na siya matangtang, no? Ang ato ang cable, no? Dahil na siya tangtangon. Naka-disadvantage sa ni class one of the terminals ng dili siya connected properly or na siya ko ano wala siya connection to the other or wala siya contact sa tuang pin. So imo na po siyang putlo no ang imong cable then kani labay ni siya no kay di na siya magamit because nakaangot naman na siya sa imuhang or gapaak na siya no ang imong terminals sa imong cable. So wala man tay device no nga wala tay ko ano tools no nga makabalik siya og pataas no sa imong terminal. So that is why kung masayop siya no na terminals nga wala siya tarong og ipit or cream so putlon gani siya no nailabay ni siya. Okay, sa ato demonstration wala tay tester karon no wala tay cable tester which means nga kay no wala tungod sa atuang kuan karon no nga pandemic then I forgot to bring no sa atuang tester. So ang ako ang madimo lang is how to uh, crimp no sa atuang network cable using a straight through cabling and crossover cabling. So the next is no the other end no, sa atuang terminal or sa atuang cable is the same na Japon ang color ng atong gamiton no sa atuang uh, RG45. So again, we're going to follow this one. So ako sa ni siya ano na kuan og shield using again sa ato ang ano okay. So ato na siyang tuyokon ang wire no. Tuyokon ang wire. Okay, then i-kuan na, no? I-throw or i-pull, no? Then, kani siyang panita, no? There will be a plastic shield, no? The anti-static uh, shield. So again, ato ni siyang bungkago, no? Ang ato ang cable nga naka group, no? Color or naka-pair siya daan ang brown o white brown. Okay, naka siya daan paired together. Ato na siyang inaton, and this one also. Okay, and the isang bungkago, no? So into, okay, and switch off. Okay, switch off. Okay, so next is the same, no? Color white orange, orange, white brown blue, white blue green, white brown brown. Okay, so white orange, and we have here orange. Okay, white orange orange, then next is white green, white green, white green, then blue. Okay, white green, then blue. Aha. Okay, matarong og straight. Then white blue blue. White white green, then blue white blue. Okay, white blue, and after white blue green, then green, and white brown brown. Okay, so next is we're going to cut this one, straight, kuan siya. Mhm. Then atong i-insert, no, ang ato ang cable. Nagbaylo, no? Sorry. So ang white green nagbaylo siya sa blue. Okay, so make sure, no, nga dili siya magbaylo ang iwang pag-insert. Okay, so and siyang tupungon. Okay, so again, white green, white orange orange, white green blue, white blue green, white brown brown. So again, check this one, white orange orange. Okay, white orange orange, and then white green blue, then white blue, green, white brown. Okay, then brown. Okay, so ato na siyang i-crimp. So crimp this one, no? Ato na siya i-crimp. Okay, so this is a straight through, no, connection. So kinahanglan ano siya, no, kuan straight through. Sorry, no, nga wala ko dala cable tester to test, no, sa ato ang pin, no, crimping. So next is we're going to demo, no, sa ato ang uh, tawag na to og crossover, no, crossover. Okay, for the crossover, so again, like I said, no, nga 1 2 1 2, okay, so siya i-try na to maximize. Okay, that one. So 1 3, no, that is 1 3 1 3. So 1 3 2 6. Okay, so simple lang, no, 1 3 2 6. Ato na siya nga demo, no? 1 3. So okay, that one. So white green sa pin 3. Okay, so ato ni siya nga i-cut, no, kay dili na ni siya ma-puslan. So we have to cut one side, no, di na siya magamit if okay. So what we're going to do is another set of cable, no, RG45. Then ato siyang this one, no, is na siya, no, uh, that is a straight through. Okay, again is ato siyang panitan, no, using sa ato ang using, no, sa ato ang kani siya nga so utang siya ga. Okay, then anong titor ng wire, no, titor ng wire, then ato i-pull, no, itong dirahon. So again, no, atong i-follow ang ato ang okay, so atong bungkago, no, ang color. So today naka-group na siya ang green o white green, and orange white orange, blue white blue, brown white brown, and green white green. Okay, so ano siyang bungkago, no, para ito siyang inaton. Kay nag-curve na siya, no, tungkol sa gi-twist mo ni siya, no, o gi-combine ato ang wire. Okay, then we have your brown white brown. Okay, then we have here green white green. Okay, so this one is steady lang siya, no, kaya mo na gi-connect ganiya sa ato ang straight through, no, straight through. So ang atong button lang sa other side is this one, no, no change niya, no, no, bali, this is our first, no, first white orange, and uh, this is our ano kani siya, kani siya nga configuration, no, sa ato ang cabling. So this is white orange orange, white green, blue white blue, green white brown brown. So dili na siya may usbon, kani lang, no, ang ato ang i-follow na pod, no, nga connection di sa ato ang cable, no. So first is white green na pod, no, white green. So where is white green? White green, this one. Okay, white green. Then next sa white green is green. Okay, green. Okay, next sa white green is green. Then next sa green is white orange. White orange, this one. White orange. Then blue white blue. So blue, blue. Okay, then white blue. Blue white blue. Then orange. Then white brown brown. White brown brown. Okay, so we're going to check no sa tuwang color coding. So we have here white green, okay, white green, green, white orange, then blue, white blue, orange, then white brown brown. Okay, so ato na siyang itupong no ato ang connection. As you have notice wala siya gatupong ng mga wires no. So kinahanglan siya nga tupungon no ang ato ang wires. So okay, so as you have noticed nga gatupong na siya no. Then next is the same no lastada sa ato ang RG45. Okay, so before i-crimp, check sa kung sakto ba, white, green, green, orange, blue, white, blue, and, sorry, white, green, green, white, orange, blue, white, blue, then orange, white, brown, and brown. Okay, so wala siya na usog. So ato siyang i-crimp, no? Crimp na to. Okay. Okay, so this is our crossover na no connection. Thank you so much no. Hopefully that naaraw idea gamay no kung saan siya pag-crimp no, sa ato ang RG45 and the network cable. Bye bye, and this is your instructor, uh, Engineer Elton Ian. Okay, would like to say thank you so much and God bless you all.